Now, I just want to wrap up some stuff today. I need to go back to the Kubernetes slides. There's one topic I need to just revisit there, and I'll also brief you a little bit on the exam next week. So let's go back to these slides first. And where we were talking about services. So we said, if you remember, that there are essentially four types of services. We've discussed three of them. We've talked about cluster IP services. That's like the reason we need services at all is because pods uh, should not, rather than cannot, should not communicate directly with one another. They will want to communicate with one another because in the majority of cases, an application is made up of multiple pods. So clearly they will need to communicate with one another. But they, rather than hard coding the IP addresses of the pod that you want to talk to, because of the nature of that IP address, it can change if the pod needs to be recreated. That's why we need services at all. Okay. So cluster IP services, you might remember, they are internal to your Kubernetes cluster. You cannot access them externally other than using port forwarding. We can always use port forwarding to access an internal service or indeed an internal pod. But other than that, you cannot access a cluster IP type service. The node port, the idea there was that you expose one of the ports in your cluster's nodes and you link that node port to a service that's running within your cluster. Now, this only works if you also know the IP address. Well, first of all, if the nodes on a cluster have a public IP address, and if they do, and you know what the IP address is, then you can access your internal service by combining the node's IP address with the particular port that has been exposed, and that will allow you to access a service. But clearly, there are security issues with that. We didn't really look at node port because we don't have access to the IP addresses of the nodes that make up our cluster. The load balancer idea is we had an image kind of describing that. Uh, yes, this was it. The idea there is that you configure a load balancer on a cloud provider. So, for example, if we were using the AWS cloud services, they have a service called the load balancer service, part of the EC2 um, suite of services. And you configure a load balancer to access a particular service within your Kubernetes cluster. Now, the issue here is that uh, your Kubernetes cluster has to be running on the cloud as well. But given that, you configure your load balancer to have direct access to a particular service running within your cluster. And of course, the load balancer has a public IP address and probably a domain name as well. So now you can access this service and by implication, these pods via the load balancer. The problem with so this service here, its type now would be the load balancer type. The rest of the configuration of this service is the same as with cluster IP or indeed node port. The problem with this load balancer approach, though, is that for every service that you want to have accessible externally, it needs its own load balancer. And these load balancers are not cheap to run. Um, so when Kubernetes was kind of launched originally back in 2013, uh, this load balancer was being used a lot, but people that were using it quickly found out that it was cranking up a lot of cost. And the reason was because, you know, a cluster might have tens, if not hundreds of services that we needed to expose or that needed to be exposed externally. So then you're paying for tens, if not hundreds. Hundreds might be extreme, but in very large organizations, there may be hundreds of services that you want to expose externally. So you're paying for lots and lots of these cloud provided load balancers. So quickly people copped on to that. And as a result of that, Kubernetes then introduced a fourth type of service called an ingress service, and that's the one we haven't looked at. Sorry, now just one sec. So the image here is trying to explain how ingress works. So with ingress, you just have one load balancer, or here I'm saying you can actually use your own in-house proxy server, which is actually what applies, I think, in the case of the Kubernetes cluster that we're using. So this proxy server is running on the same kind of hardware as our cluster VMs, but it's kind of external from the cluster, if you like. Either way, whether you have a cloud provided load balancer or a proxy server that's running on your own hardware. Uh, so that's one part of ingress. Here we have our services. Okay. These are two services, but their type now is ingress as opposed to cluster IP or node port. And as always, a service is linked to a particular deployment. So we've got Maria here, the to-do UI deployment, and over here we've got the to-do API deployment. Now, the other really important part for Ingress, though, is this component here. This is actually a pod, but you don't control this pod. This pod is set up by the cluster administrator. And this pod we refer to as the ingress controller. And so when a request for one of these services, i.e. one of these pods, when the request hits the load balancer passes it on to the ingress controller pod, and it then decides which service it should send the request to. And it does that by means of the ingress manifests that you have applied. Over here, we have an ingress manifest, a service manifest, but where the service is of type ingress. Sorry, no, I lost my mouse. You can see here it's of kind ingress. And in this ingress service, you essentially specify rules, mapping rules, and the rules are used then by the ingress controller to decide where it should send the request onto, which service, which ingress service should it forward it on to. So within any particular Kubernetes cluster, you could have lots of these ingress services that you have deployed. And essentially, for every ingress service that you deploy, the ingress controller kind of reads the rules part and it keeps its own internal, let's call it a database, right? Of all of the rules, all the mapping rules. And then it looks up those set of rules to make its decision as to which ingress service it should send the request onto. So for each of these services here, there will be a manifest file that caused essentially the creation of these services. But outside the cluster itself, you have one load balancer or a proxy server. And obviously that's much cheaper. Now, just to give you an illustration of it, right? So what I have is, if I go OC get pods. Okay, so I've got three Nginx, yeah, three, is it three or two? Three Nginx pods that are all part of the same deployment. This other one here is irrelevant, right? And you can tell from the names of the pods anyway that they are actually part of the same deployment. So that's fine. That's my kind of replica set, if you like. I also have um, I also have let's see, I have a I've got a service, and I'm telling you, but this service, right, is sitting in front of these pods, right? I've set that up already, and we know how to do all of that. Now, the next piece of the jigsaw is the ingress part. And so up here, I've got an ingress service. And so its API version is whatever it says up here. I obviously found that out. Same, we know the kind of routine now at this stage. If we go OC API, and if I do a grep on ingress, then let's see, which one is it? It's this one here. We know how to find this information. So I've already done that. I'm thinking it's this one here actually. So I found out what the API version is, and it is what I've put up here. Um, I've got the kind as ingress. I've got my metadata. The only piece of metadata is just the name and the spec. And the spec in this case is slightly different, obviously, because of what it's representing. So in the spec, you would have, in general, you could have multiple rules, right? So this, you can see the rules thing here is an array. So you can have multiple rules, but I've only got one. The host part is essentially that's telling us what is the URL that we can now use to access our pods or to send a request to our pods. Now, so the host is just a domain name. Well, it's subdomain name actually, right? Now, this domain name here, if I just take, let's say, this part of the domain name, that is dictated by the proxy server that we have configured. So this domain name here has been registered as the domain name. If I go back to my slides, for the load balancer or the proxy server, whichever way you're configuring this. So you have no control over the domain name. That's dictated uh, by the cluster administrator, if you like. But then you can add a subdomain onto that, and that's what I've done here. So DO Connor, DOC Nginx. that now gives me the full URL that I can use in a browser or any type of client, Postman or whatever. And I want that URL to eventually send a request to one of my Nginx pods. The rest of the spec then, you specify paths. So there may be multiple paths that are relevant to my pod. By paths, I mean, what appears after this. So slash something. There may be a number of paths that apply to our particular uh, pods that we're trying to send requests to. Doesn't arise in my case. Um, so that's why under paths, I only have I only have one path. And the different parts of the path are uh, what is the actual path itself, and I'm just using the root path. So I just can I just stop for 1 second, please? Sorry, I just wanted to mute my phone there. I didn't want to go off in the middle of the lecture. Where was I? The paths, yeah. So the only path that I have that's relevant to my pods is just the root path itself. The type, well, there are a couple of types with prefix. I'll explain what prefix type is in a moment. And then the back end is, well, where do you want this requests that are directed at this URL? Where do you want them to go to? And I want them to go to my Nginx service. So I have my Nginx service here, and the port that the Nginx service is listening on, port 8081. The service itself, we actually had it before, but here it is here. Is that the one? Yeah, Nginx service, and it's listing on port 8081. Okay, back to my ingress. And that's it. Okay, so that's fine. Now, this is just a manifest. So you just run is OC apply this manifest file. And if I now look at, if I go OC get ingress, or ing is the short name for ingress. And I've got, what have I got? I've got one, this one here. This is the one that I've just created. The other one is a default one that seems to have been created automatically by for my account, if you like. So that's my service. If I do a describe on it, grab this guy. It's telling me what are the various rules, which completely match the manifest file. Surprise, surprise. The upshot of all of this is, so I now have my Nginx pods. I have a cluster IP service in front of those pods, and I have an ingress, which has a rule that's pointing at that cluster IP service. And I can now just grab this URL I don't need to use port forwarding now anymore. Just grab this URL. In my case, go to a browser, but it doesn't have to be a browser. Client can be anything. And voila, I get a response back from one of the pods in my replica set. Yeah. So, and again, as I said, I don't have to use port forwarding anymore. So ingress is the way, um, is the kind of production standard way of exposing uh, some internal functionality within your Kubernetes cluster. Now, if I actually go, slash ABC, uh, the 404 not found here, you can see it's actually coming from Nginx itself. It's coming from the Nginx server. It's not being generated. This 404 is not being generated by, my proxy server. All right, go back to my slides. It's not being generated here. It's not being generated by this ingress controller because it actually knows that the URL should go to my Nginx. If these were my Nginx pods, and this was the cluster service in front of those, it knows it should send it to that. It essentially ignores the Nginx controller ignores the slash ABC part of my URL. Uh, and the reason it's doing that, the reason it's ignoring it is because I do not have a kind of a mapping in my set of rules for slash ABC. If I go back to my ingress manifest file, I would need to have another path for slash ABC, and I don't have one. But the path that I do have is of type prefix. And what prefix means is it's essentially telling the ingress controller, ignore anything after the slash. If there is something after the slash or the root path, if you like, in the URL, then just ignore it and just forward it on to this backend anyway. So the slash ABC now is now received by my Nginx pod. And if it had a mapping for slash ABC, then it would return the response, the H. Uh, can I check? I'm pretty sure now people can hear me or hear me. I think I lost you there for a minute, did I? For a second.
Yeah, it was kind of breaking up a little bit.
Is it? Yeah. Okay. I'm nearly finished anyway. In fact, I think I am finished. So, okay, look, that's it really. Like there isn't much more I need to say about English. There is some other stuff as well, like the difference. If I go back to my manifest file, I'm not sharing, I think, with you, am I? Did I lose you again?
It's all working out.
It's coming in and out though, is it?
I think it's just working. You after your screen just came back there.
Okay. I think now what's actually happening is I'm using one of those modems that's okay, has it been choppy up to now?
Most of the time it was good. It was just like 2 minutes ago when it started going bad.
Okay. Right. And I am sharing. Okay. What I might do is I'll just share this ingress controller, sorry, this ingress manifest file on Slack with you so that you just have an actual, because it didn't arise in the lab. Uh, and so you could use it yourselves if you wanted to use it. Just tag it on to. The only thing you have to be aware of is that in terms of the host, you know, each of you have to pick a different subdomain. So maybe just use your initials or something else because, we're all working on the same cluster, and uh, it's kind of a case of who gets in first with a particular subdomain. Everybody has to use this part of the domain that's configured by that's kind of linked to the proxy server itself. So we've no control over that, but the rest we do have control over. Um, and you could set up an ingress that maps to the Mongo Express uh, service from the lab. And that brings me back to the labs, actually. What I was just saying there is this lab here, right? You've worked your way through all of this. Uh, you could just add an ingress controller where's my image? If I go back to an ingress controller, sorry, I keep calling it ingress controller, an ingress service that's linked to the Mongo Express service. And then you'll be able to access this Mongo Express service, and by implication, these pods, without having to use port forwarding. Up to now, you had to use port forwarding in order to be able to display the Mongo Express web app in your browser. Right, that's the end of the lecture part. I now want to talk a little bit about the exam. The exam, I'm scheduling it. I'll communicate this confirm this on Slack, but I'm trying to schedule it for Wednesday, the 10th of December, which would be the Wednesday of next week, from maybe starting around 10:15. I'll give you the exact times in Slack later on. But I have to book the room first, and that's taking a while to get somebody to book it for me. The exam will have two questions. One of the questions is going to be worth 20%. The other one is going to be worth 80%. I want to talk about that one mainly. So if you remember, um, how will I approach this now? So the question, the 80% question will require you to set up a multi-component application. In the lab, this lab here, you have set up a two-component application, the Mongo database and the Mongo Express. So it'll be something like that. There may be two or there may be three or whatever components that make up the application. And the way I'll describe how you might set up the application, I will describe it as if you wanted to set it up on Docker desktop. Because if you remember this application here, if we just talk about this, right? We set up this application on Docker desktop back earlier in this semester. And so if I go back to that earlier lab, which is here, and is here. Okay, look, it's the exact same application that we set up back then. And the way we set it up back then was because we were using Docker Desktop. I gave you the Docker commands, and the Docker commands in that case was, here's how we started up the Mongo. Uh, we didn't call them pods, the Mongo container. That's how we started it up. And this is how we started up the Mongo Express container. Now, in the exam, I will give you the Docker commands that you would use to set up the multi component application. But you've then got to take that information and set up the same application in Kubernetes, write the manifest file. You don't have to set up the application in Docker Desktop, and you shouldn't really. I wouldn't waste time doing that. So what I will provide again is, as I said, is I will provide the Docker Desktop commands, these ones here, as if you were setting up this multi-container application on Docker Desktop. But you need to take that information and set it up on Kubernetes as a set of pods and services and whatever uh, manifest files that are required, all the manifest files that we've looked at during the Kubernetes section of this module. So that's the way the question will be kind of presented to you. Again, at the risk of repeating myself, I'll tell you, look, it's a multi-component application. Here's a visual representation of it. That might be something like, you know, like this. Uh, Here are the Docker commands that you would use to set it up on Docker Desktop. Now you go away and set up that application in your Kubernetes cluster account. Okay, full stop. Any questions, I wonder, about that?
Would we be carrying this out just on our own laptops inside of a testing room? Is it?
Oh yeah, okay, yeah, that's good. I should have said that as well. So the exam will be in one of the labs. I'm trying to book IT 118. You bring along your laptop, and you'll be doing everything on your laptop. You log into your uh, Kubernetes cluster account. I'm going to have a 5G modem in the room because, as you know, you cannot log into your Kubernetes account using these college Wi-Fi. So I'll have a modem in the room, and I'll explain to you before the actual day of the exam how you connect to the modem. I essentially need to tell you what the name of the modem is and what its password is in order to connect to it. So you'll be able to then log into your Kubernetes cluster, uh, and I'll provide the exam online to you, the actual text of the exam online, and away you go. Yeah. Any other questions? Now, I'll also provide a starter GitHub repo. There'll actually be very little in the repo, but you will still need to fork that repo and clone it onto your own laptop. And you will need to send me the GitHub URL of your fork of that repo that I'm going to provide. I will provide it over Slack in the coming days. And you'll do that all in advance of the actual exam itself. You will send me via Moodle. I'll provide a Moodle link. You'll send me a text file, just like you did with the assignment, really. And in that text file will be the URL of your GitHub repo. And your GitHub repo will be a fork of my GitHub repo. And as I said, there'll be very little in it, but you need to do that anyway. And in the exam, then, as you create your various files, you will need to do a git commit after each file that you create, each manifest file. If you make a change to a manifest file, because you may need to change them, because something isn't working, when you make a change, you have to reapply it. Every time you reapply, you should do a git commit to your GitHub, to your local Git repository. You can do git push multiple times during the exam if you want to. You don't have to. As long as you do a git push at the end of the exam, then all of the commits that you would have done during the exam will be pushed up to GitHub. But you can do a git push a couple of times during the exam if you want to. But you must do your git commits during the exam. Otherwise, it won't be corrected and you'll just get a 0. And I will state that at the beginning of the exam paper.
Is it gonna be open book exam?
It is completely open book in the sense that you can access
Oh,
any
perfect.
of the, you can access the websites,
Lectures.
you can access the labs that you've been building up over the last few weeks. You can use any online resource except AI.
Yeah, that makes sense.
Yeah.
Thanks.
Anything else?
Yeah, how long do we have for the test?
Um, I haven't decided, but it's probably maybe it'll be over an hour anyway. So
Okay.
it might be 70 minutes, 90 minutes. I haven't decided yet. That's the 80% question. The 20% question will be on Docker networks, and I'm not certain whether I'll include that question or not. So there may be actually only one question. But if there is a second question, it will be mainly on this stuff here, right? And that will be worth 20%. But I'm inclined to, thinking out loud, to not include that part to it and just let you work on the Kubernetes one. Whether I include the second question or not, that will dictate whether the exam will be a 90-minute exam or something shorter than that.
Okay, thanks.
Do you have any updates on CA1?
I actually published and I was going to send a Slack message about it this morning before this lecture, but I didn't get around to it. But I have actually published the results. So if you log into Moodle, you will find your mark there. And
Perfect. Thank you.
and a breakdown of small enough kind of breakdown of the mark. What I found when I was correcting them was, that they were very good. I'm hoping people didn't over rely on, I don't know if people use AI or not. The reality is that people may, but and they well, I gave the mark just based on what I saw. I didn't kind of assume, or I didn't try and second guess. I wonder that people actually find out about the extra features that I saw in the GitLab CI file. Did they find out about them just from doing kind of traditional Google searching, or was it more AI based? But I'm not going to question it one way or the other because I can't prove it one way or the other. So the mark you got anyway is the mark that you got. Yep.
Oh, yeah. Yes, sir. For the pods that we created during the labs, are we able to delete those now before the exam, or should we just leave them up?
Yeah, I think it's a good idea if you did. I'd say it might be a good idea to clean up your account in terms of pods and services. I mean, you have the original manifest files anyway, so it would only take no more than 10 minutes to recreate them all again. So I think it's probably a good idea to clean up your account uh, before the exam. Yeah, your Kubernetes account. That would probably be a good idea. You don't have to, but
Okay.
I would be inclined to do it. Otherwise, it can get a little bit clustered. And as I said, you have the manifest files, so it's just a case of OC apply the various files if you want to recreate it and play around with them at any stage.
Where on Moodle did you publish the grade?
No, you should get them
Struggling
in the
to
normal way.
find it.
It's in the
Unless I left.
assessment section. Better go to assessment.
'Cause I'm seeing grades, but
It's where you would normally get them. I presume you're familiar with this stage as how you access grades for CA for any module that are published on Moodle.
okay, I'll check it again. Thank
Yeah,
you.
come back to me if you can find it. Yeah. Okay. Have we got any other questions? I don't intend holding a lab tomorrow morning, but I'm available on Slack anyway, so people need to contact me. And I will be in touch with you over the coming days about that GitHub, that kind of starter GitHub repo, uh, and some other stuff as well if I need to communicate with you. Right, we'll leave it at that, and I'll be in touch with you. Thanks, bye-bye.